going to be starting acids and bases. The lesson today is going to cover hydronium ion. The learning goals for today are to describe the properties of acids and bases, name acids and bases, define hydronium ion, and describe the ionization of water. So I want to see what sort of background information you guys have before we move on to the unit, before we start. So I want you guys to take a minute, fill in this table as best you can, and when you are ready, press unpause, and then you can check your answers with. Okay, so here's generally what students come up with when I ask them this question. They'll say that acids are sour tasting, they have a pH less than 7, they turn litmus paper red, but there's a couple extra that I want to add here. So from our previous unit, we also learned that acids ionize in water. So ionize in water. Another thing is acids are an electrolyte, so they can conduct electricity in solution. Lastly, acids react with metals. So for example, zinc, maybe magnesium, etc. So if you were to drop a solid metal down there, it would react with it and form some bubbles and gas. Okay, so now some things with the base. They're bitter tasting, they have a pH greater than 7, and they turn litmus paper blue. Some points to note here. Bases do not react with metals. So do not react with metals. And bases actually dissociate in water. And because they dissociate, they form ions, and so they are an electrolyte as well. Okay, so now we're going to move on to naming acids because we are going to be dealing with a lot of acid names in this unit, and I want us to be comfortable with naming and identifying what an acid is when it's named to us. Okay, so the first type of acid name is when something ends in "ide." So for example, chloride, okay? If it ends in "ide" and when it gets a hydrogen ion and turns into an acid, we will name it as hydro blank. So whatever the anion was, which was chloride, so it's hydrochloric acid. Okay, so for example, I have this here, HBr. This Br attached to the H is bromide. Okay, it's the bromide ion. Okay, ends in "ide, therefore we're going to name it like this. So it's going to be hydrobromic acid. Perfect. Moving on to the next one. If it ends in 8, okay, so you're looking at your polyatomic ion in your data booklet. If it ends in 8, so for example, chlorate, we will call it chloric acid. So the difference between these two is we're not putting hydro in the front, okay? So this would be chloric acid, or if we had perchlorate, it would turn into perchloric acid. So here we see we have sulfate attached to our hydrogen. Ends in 8. So this will be sulfuric acid. Okay, and the last acid name that you have, so let's say on the polyatomic ion chart, something ends in ITE, ite. Okay, so let's say we have chlorite. It's going to get an ending of OUS when we give this acid name. So again, there's no hydro in front of it, and we are now changing the ending to OUS. So here, attached to the hydrogens, we have sulfuric bite ends in ITE, so this acid will be sulfurous. Sorry, let's clean that up a bit. Sulfurous acid. Sulfurous acid. Perfect. Okay, so then we will be asked to work backwards. Sometimes they'll give you more likely they'll give you an acid name and you're going to have to identify it based on the name. So carbonic acid, there's no hydro in front of it, and I see an ending of IC. So that means it's something that ends in 8, okay? Carbonate is the anion attached to the hydrogen. So the acid will look like this, H2. Oh, that's definitely not carbonate. Carbonate has a -2 charge, okay? Depending on that charge, that tells you how many hydrogens you'll need. It's just like an ionic compound, so CO3. Perfect. Here we have hydroiodic acid. So I see hydro, I see ic. That means it is an ion ending in ide, okay? Iodic, that means it's going to be iodine, or sorry, iodide. That's going to be hydrogen attached to an iodide. And lastly, we have nitrous acid. Nitrous acid, that is going to refer to our nitrate ion. Okay, so our nitrite ion is NO2 minus, so that means we're going to have one H in front. Okay, so this is how you name acids. Bases, on the other hand, are going to be like ionic compounds. We're going to name them with ionic compounds. And the most common type of base that we will see are metal hydroxides. So basically, when you're naming them, you name them just like ionic compounds. You give the full name of the metal and you write hydroxide after it. So let's say we have KOH. The name of this ion, or this, sorry, ionic compound would be potassium hydroxide. Okay, let's do another one. Let's say we have AlOH3. This one would be aluminum hydroxide. Let's do one more. We have barium 2 hydroxide, so that's going to be barium hydroxide. Perfect. One base that does not follow this rule will be ammonia. So ammonia is actually an acid, sorry, a base. So I'm just going to say that down here. Ammonia is also a base. Just so that when you see it, you know that you're talking about a base. Okay, let's get to this, the root of this lesson today. We're going to talk about the hydronium ion, okay? There's this beautiful ion right here, H3O+. You'll notice that it's formed when we take a water molecule and react it with a hydrogen ion, or as we say, a proton. And that gives us a hydrogenated proton, which we will now call hydronium. So hydronium is a hydrated proton. So a hydrated proton. Basically, a water molecule with an extra hydrogen on it. So basically a water with an extra hydrogen attached to it. So before, water was considered to be a non-electrolyte. However, it has been found that with a very sensitive apparatus, so a very high-tech, very accurate conductivity meter, it is discovered that water is actually weakly conductive. So it can conduct electricity, but very weakly. So what makes it weakly conductive? So why is water weakly conductive? Basically, water is weakly conductive because water slightly ionizes. Basically, what happens when two water molecules collide with each other, they produce hydronium and hydroxide ions. Okay, hydroxide looks like this, OH minus, and hydronium, we just learned about it, looks like this. So here's what happens. Let's use some different colors here. We have two molecules of water. They're reacting with each other. Oh, water is not aqueous, water is liquid. So when they collide with each other, one of the hydrogens gets transferred to one of the molecules of water, okay? And then what happens is it produces hydronium, which is my positive ion, and then it produces hydroxide. So you see that it forms the two ions. And like I said, if something forms ions, it's an electrolyte. It's able to conduct electricity. That's what we learned in the past unit. So then why is it weakly conductive if it's forming ions? Well, the reason is only one in a billion water collisions result in the formation of hydroxide and hydronium. Okay, so it's because it's 1 in every billion collisions result in hydroxide and hydronium. So it's a very small percentage. All aqueous solutions have some hydroxide and some hydronium or a hydrogen ion. So before we move forward into this unit, I want us to realize that whenever I'm talking about hydronium from now on, that means it also refers to me talking to H+. These two are going to be seen as equal for the rest of the unit.